In this problem, we have a quadratic function, and we want to find its vertex, the vertex of the parabola, and sketch its graph in the easiest way possible, I guess without using a graphing calculator. This quadratic equation looks pretty gnarly. It's kind of messy. It looks like it might be hard to factor. Other things about it are annoying to try to graph it. But there's an easier way to graph a parabola from an equation of a quadratic, and that is to put it in this form. This form, sometimes called vertex form, will give you the vertex of the parabola. And once you get the vertex, it's pretty easy to graph the rest of the parabola from that. What you need in this form is this perfect square here. So x minus some number, quantity squared, and then it can be multiplied by something and then have some number added to it. And the point hk is going to be your vertex. So let's see if we can wrangle this into this form. I think the first thing I'm going to need to do is work on completing the square. So I'm going to isolate the x pieces here and just think about those. In this chunk, negative 2x squared plus 20x, I think the first thing I'd like to do is just factor out a negative 2. And that way I'll just have x squared here. That's going to be a lot easier to deal with. And if I factor out a negative 2 from the plus 20x, I get negative 10x. And then I've still got this negative 51. I'm just going to put it over here so I don't forget, but I'm not really paying much attention to it right now. So this chunk in the parentheses, I want to turn this into a perfect square, and I can do that by adding the right number. So let me actually move this set of parentheses over here. The way we do this, when we have x squared and then some number times x, we take this number and we divide it by 2. In this case, negative 10 divided by 2 is negative 5. That means my perfect square is going to be x minus 5, because it's a negative 5, x minus 5 quantity squared. Now, to make this work out, here, I need this third term, which is that negative 5 squared. So that's a plus 25. And that's all well and good, except I've just added, well, it looks like I've added 25 to this equation, but really I've added negative 2 times 25. So I've added a negative 50. So to balance this out, I have to add back in 50 to cancel out the negative 50 that I just put in right there. Now we can rewrite this. This chunk right here is this quantity squared. Then I've got my negative 2. And then negative 51 plus 50 is just minus 1. So this is g of x. I've just rewritten g of x in this vertex form. And we can pull off our vertex. It's negative hk, so our vertex is 5, negative 1. Oh, I guess I wanted that here. 5, negative 1. All right, so far so good. I think we can start graphing. I notice, well, my vertex is at 5, negative 1, and I've got a negative a leading coefficient. So it's going to be a downward opening parabola. So I'll put my x-axis there. We'll put the y-axis here. Okay, so let's go ahead and plot the vertex. 5, negative 1 would be right here. And then let's take points on either side. So let's look at 4 and 6. And these we can just plug right in. If I put a 4 or a 6 in here, I'm going to get 1 or negative 1. When I square it, I'm going to get 1. Actually, let's make a little chart here so we don't get confused. So I'm putting in a 4 and a 6. So I get 1 squared times negative 2 is negative 2. Negative 2 minus 1 is negative 3. So for both of these, I get values of negative 3. So there and there. And let's go one further out. So 3 and 7. If I put a 3 in here, I'm going to get a negative 2. If I put a 7 in here, I'm going to get a positive 2. Either way, it's 2 squared is 4. So 4 times negative 2 is negative 8 minus 1. That's going to be negative 9. This is a narrow parabola that goes down pretty fast. So negative 9. So let's see. This is 3, 4, 5, 6, 7, 8, 9. So I think right there and right there. And once we've got that many points, we can just kind of sketch in our graph. So that is how to manipulate the format of the function to put it in this vertex form so that we can graph our vertex and then easily graph the rest of the parabola.